Hello, and welcome to our database group presentation for ITCS 1170 V1650 for fall 2022. We are Group 3. Our SQL Server Management Studio project is for Bladeworks Unlimited, a landscaping company. Our group members, Jordan Rathwell, Team Lead, Brandon Mercado Franco, Matthew Kalinin, and myself, Stephen Boley. We will give an overview of our database, discuss the ERD, business rules, and data constraints, touch on the table scripts, and the queries that were built to test the capabilities of our database. Matthew will now provide the overview.
For a general database overview, our fictional company, Bladeworks Unlimited, is a landscaping company that operates in the United States to provide landscaping services to households and businesses. Our database for Bladeworks Unlimited stores a lot of data concerning customers, employees, equipment, services, and more. Data entry, corrections, and updating for this database is made to be easy to input. Close to 80 people's information is listed within the database. This includes individual customers, commercial customers, and current and former employees.
Let's talk about Bladeworks Unlimited's entity relationship diagram. In order to achieve our database goals, we needed a functioning logical model to feed our physical design later on. Our domain entities are the core components of our business, and they are highlighted in yellow. Each of them has a unique primary key. Without them, Bladeworks cannot exist. These are the people that make up our company, including our customers, the equipment that we use to render services, the services that we provide to our customers, the estimates that we provide to our customers for referencing integrity and greater customer service experiences, as well as the invoices that are produced upon completion of work in order to ensure that our Bladeworks employees are getting paid. We have three lookup entities in our entity relationship diagram, and these are the employees, residential customers, and commercial customers. And these are part of a super subtype relationship, with the person entity here being the super type, and these other three types of people being the subtypes. We also have very many linking tables that link our primary domains together in order to make querying our database faster and providing efficient pathways for table joins when we're querying as well. In this example, here, service equipment, both attributes are primary keys and foreign keys in other tables. In the lawn care industry, you would not use a weed whipper to cut an entire lawn. In order to enforce certain business rules, we use this linking table here. Each service that we provide requires the right tool for the job, and no other way will it be done. Employees on cleanup detail will use leaf blowers, and people cutting larger lawns, they would use a zero-turn riding lawnmower. And this linking table here ensures that each service is linked to one type of equipment. We have many other linking tables here, but what we do not have in our ERD are weak entities. We avoided using any entities that would need to provide extra context for another entity. We just figured the data wasn't useful to us and it would save us time and headache down the line. With that, I'm going to pass it over to Matt, and he's going to talk to you guys about some of our business rules and constraints.
For the business rules and constraints, business rules. Customers can either be individual people or businesses. Employee equipment must always be assigned to a specific employee. A name should always be recorded for a commercial contact. For constraints, invoices must have a quantity of services attached to them. Prices charged cannot be negative values. And customers must be marked with either a Y or N, a yes or no, for being active and inactive, respectively.
Now let's talk about the script. So each table was generated one-to-one from the ERD model diagram. Most data types were taken one-to-one, but we did have to work a couple things out, such as the data type time. Initially, when we were working on the ERD, we just assumed that there was a time data type, so that had to be changed to decimal, and we were going to measure that in hours. Additionally, Boolean, that was kind of the same story. We changed that to a char1 and restricted the values to y or n. We added some constraint checks for the currency attributes. So all of those were going to end up being positive values. And we did have some difficulties with the primary keys, where that necessitated a little bit of rework in the script and the foreign key constraints. So now let's take a look at the script itself. So here's the script. At the top here, we have some statements to create the database, and then we get into the table creation. So here's how we created the person table, the employee table, the customer table, and likewise. Once we created all the tables, our next step was to populate data into those tables using the insert values. So this is an example of the data that we used for person. Here's some that we used for employee, and here's what we did for commercial customer. And a side note, the data here that we used was all these are not real customers. This was automated automated data sets that we used to populate here. One thing I want to point out is that in cases like this, where we were populating a lookup table, we had to be careful that the combinations of the values being used here were always unique, because in this case we had a compound primary key that was based off of the two values here, so you can't have any repeating combinations. Otherwise the script will throw an error. So once that was all completed, then we moved on to building our queries, and we will discuss that next.
Everybody, my name is Brandon, and I will be sharing our group's queries. So these queries for our database were based off of questions that a business manager or owner might have about their own business and its operations. And the thought process behind these queries were all questions relevant to our business, because this type of information is useful, that it would help the business maintain tax compliances, maximize revenue, and reduce unnecessary spending. So I'm going to show you guys our code. Just give me 1 second. All right, thank you. So let me show you our first query. So this first query shows all of our current employees, by using the where clause and the end date is null function. So let me take a look. We have 9 employees currently employed with Bladeworks Unlimited. Our second one is a query that will show a list of our customers who have not yet paid, and it's important for a business to, know which customers haven't paid in order to, get that profit that the business needs to stay afloat. Gladys, Veronica, Ezekiel, Chris, Willard, and Alicia both all have some explaining to do. All right. And our third query deals with the names of people associated with our business accounts. All of the business accounts have to have someone's names attached to it. It's a common practice that most businesses who use a database have implemented. I've seen it myself in my job as a financial service representative. All right. And that fourth query is a subquery used in order to find out which equipments our running maintain costs are over the average maintain costs. So this will tell us whether or not to keep that piece of equipment or is it time to replace it. Because equipment is one of the biggest costs that a business has to go through. And we have to make sure, that it's worth, keeping up. Otherwise, we should just replace it. And let's see right here. The next one is a query used to find employees who are not associated with the type of equipment. So this would mean that this employee is relatively newer, maybe they're in management, maybe there's something else along the lines that, they haven't been able to touch a piece of equipment yet, or maybe it's an error on our end that they're not associated with one yet. So it's a good thing we have that data in order to, answer those kinds of questions. All right, and our next query is to find the frequency of estimated times given to customers. So this means that we're going to be looking at the data that we give to customers. How much time is it going to take to finish a certain job? So let's take a look. So estimated times of 1 hour, 3 hours, 2 hours. So it looks like, relatively speaking, 1 hour and 3 hours are of a higher frequency than the 2-hour jobs. And this last query gives us the frequency of estimated times that are over an hour. So we can find out which kind of jobs are taking longer time, which jobs, should we alert customers about that it's going to be a little while versus, the standard 1-hour job. Thank you so much for listening to the queries explanation of our presentation.
Thank you for joining our presentation. Working on this project was a pleasant experience. In our previous segments, we highlighted our business rules, constraints, and how Bladeworks functions as an organization. Thank you, Matt. Jordan provided insights into the table building process. Brandon detailed our queries, and I covered how our ERD is structured. We hope you found our presentation informative. If you have questions or comments, please click the reply button below our video and type out your inputs. We will answer as best we can. Again, thank you very much for your time.